Alright, so here we're graphing. It's a quadratic equation. Happens to be in vertex form. Notice the parentheses there. So when we look at this equation, we see that a is -1, and then our h is right here, and the minus is already there in the formula, so the h is 4 and the k is 2. So we already know that we have a vertex at 4, 2. And since a is negative, we know it's going to open down. The axis of symmetry always goes through the vertex. So when we're graphing in vertex form, we're able to spot the vertex right away and then graph the axis of symmetry, which is the vertical line going through it. So we have already completed the first two steps of when we do it in standard form. So vertex form, a little bit different. We're going to look at the equation, find the vertex, plot that point, and then do step one, which was to graph the vertical line, the axis of symmetry, going through that vertex. But now we have the first two steps done already, and we're ready to pick some x values to the right of the vertex. So let's put 5 in. So we're replacing y in our equation, or excuse me, x in our equation with 5 and solving it for y. We do what's in parentheses first. 5 minus 4 is 1. Then we'll do the exponents. 1 squared, 1 times 1 is 1. The negative sign is in front of the 1, so now it's opposite of 1, or -1. -1 plus 2 gives us 1. So we have a point at 5, 1. Then we'll put 6 in, so replace x with 6 and solve for y. So we have 6 minus 4, that's 2. 2 squared is 4, the opposite of that's -4. -4 plus 2 is -2. Put 6 in, we get -2 out. We're going to reflect these points across that axis of symmetry. Oops. And then we'll connect those with a smooth curve. Well, somewhat smooth curve. So you should see a parabola opening down. It has a vertex at 4, 2, and then you can see those other points. This one is still in vertex form. It's also in function notation, but f of x means the same thing as y. So if you want to, you can graph the equation y equals 3 times in parentheses x plus 2 close parentheses squared plus 1. And that's going to be the same as this f of x equation. The graphs will look exactly the same. So if we look at this, we can tell that our a is 3. The h now has a minus in front of it, so it's the opposite of what we see. So the h is -2. And then the k is 1. So we have a vertex at -2, 1. So plot a point at -2, 1. Axis symmetry always goes through the vertex. So we can graph that point, or excuse me, that line going through that. So we have those first two steps done from if you're looking at the steps for standard form. Next, we'll pick an x value to the right of, actually two of those, to the right of the vertex. So we'll replace x with -1. Now the left side stays the same the whole time. We won't change that. On the right side, -1 plus 2 is 1. 1 squared, 1 times 1 is 1, and then 1 times 3 is 3, and then 3 plus 1 gives us 4. I guess I could have showed one more step in there. So we have a point at negative 1, 4. So f of negative 1 equals 4. What this means is when you put negative 1 into this function, 4 comes out. Again, y and f of x are interchangeable here. It's emphasizing the fact that we have a function. So if you want to write f of x here, you can, but it's not a big deal. Now let's put in 0 next. So we're replacing x with 0. 0 plus 2 is 2. 2 squared is 4. So we're finding f of 0. Multiplying x, 3 times 4 gives us 12. And 12 plus 1 gives us 13. So if you were wondering why they gave us such a big grid, that is why. Now we'll reflect those across that axis symmetry, or mirror those. So the point negative 1, 4 reflected across becomes negative 3, 4. And then the point 0, 13 reflected across becomes negative 4, 13. Connect those with a smooth curve and you'll have your parabola. Notice it's a parabola opening up. The reason it's so steep is because of the a value. And a is positive, so it is opening up, but it's very steep because of that 3. Hopefully that's helped you learn how to graph parabolas in vertex form. More videos are on my website if you need them. Let me know if you have any more questions.